Hi, sweetie. Wait, where did you go?
Come on, come on. No!
Did they just say aliens landed?
When a DDoS attack happens, it's not just the big companies that feel it. It affects real people like you. Too much fake traffic causes real disruption. This is a DDoS attack. With smarter, faster detection, we can keep the internet flowing because every connection counts. Our designed FPGA-based CNN firewall for real-time DDoS detection, featuring high accuracy, fast adaptive response, and ultra-low latency.
Okay, so this is a DDoS protection industry overview. The global DDoS protection market is growing at 14% compound annual growth rate, reaching $8 billion by 2032. A single hour-long DDoS attack can cost an organization around $44K US. The number of DDoS attacks has nearly doubled from 7.9 million in 2028 to 15.4 million in 2023. Our FPGA-based CNN firewall delivers more than 99% accuracy detection, real-time low-latency DDoS defense, and flexible model update through reconfigurable hardware. So our presentation is going to go through three aspects. Traditional firewall struggles to detect dynamic and evolving DDoS attack. Industry leaders are shifting towards AI-enhanced hardware-accelerated firewall solutions. FPGA-based CNN architecture enables real-time model updates for new DDoS threats.
Right, next I'm going to go over the limitations of traditional firewall solutions and what are the advantages of the design we proposed. You have already seen our video. We have all experienced times when websites or video call load painfully slowly or connection suddenly lost. Even our grandparents may have noticed it. One major cause behind this frustrating moment is a DDoS attack, distributed denial of service. This image illustrates how a DDoS attack works. An attacker uses a bot to send massive amounts of requests to multiple DNS resolvers. Then these requests are amplified and redirected toward the final target victim, which could be a server, a company, or even us as an individual user. This overwhelms the system and makes the internet feel slow, unstable, and unreachable. Now let's take a closer look at why traditional firewall solutions struggle against modern attack, like DDoS. This table compares several solutions: CNN, Snort, Selic, Gao, and Javed. As you can see, our CNN-based solution checks all the boxes. It supports early-stage detection by analyzing just the first few hundred bytes of traffic to predict attacks. It maintains a low false alarm rate, accurately distinguishing between normal and malicious traffic. It works across different protocols, automatically extracts important features, and can directly process raw traffic data without a need for manual pre-processing. However, Snort, which is a classical firewall solution, heavily relies on signature-based pattern matching. It requires a large amount of packet data to perform fingerprint matching and depends on manually designed rules set to detect threats. Similarly, while Selic, Gao, and Javed adopted deep learning techniques, but their approach still depend on manually extracting features and designing detection rules, which limit their adaptability and automation compared to CNN method. So what is CNN? CNN is convolutional neural network. It is a type of deep learning model that can automatically find important patterns from data without human interaction. For example, on this image, the CNN will be given a zebra picture. and the CNN, and then it will go through the CNN architecture and classify if the picture is a zebra or any other kinds of animals. Here is a experimental result from multiple research paper, and we found the CNN provides extremely high accuracy, as high as 99%.
Okay, so let's take a look at industry leaders standing in integrating AI with hardware-based firewalls. So Fortinet has FortiDDoS, but their design is basically using statistical analysis with huge database, which is expensive and out of date. For Cisco, they have not yet developed any hardware protection products. Software is not enough to reach the real-time DDoS detection. Palo Alto has a solution with the optimized static deep learning models, which is not enough, while Xilinx is working on similar things, but their hardware structure is reconfigurable. They are still working on it, and we are doing similar things with a little bit difference. For Huawei and Nvidia, they have the most powerful anti-DDoS machine so far, with lots of AIs, huge throughputs, and huge databases, but their power consumption is so high, and their products is really expensive. So how expensive are Huawei and Nvidia? Their hardware average cost is more than $1 million US, which is absolutely not affordable for medium and small companies. That is the reason why Palo Alto is making money, and Xilinx is also trying to do something similar or better. So what Palo Alto do is pick the best statistic neural network model and to detect all types of DDoS. But why this method is not enough? According to the table that I showed you before, when we look into that, we will find that all CNN models can reach such high accuracy because they are using specific datasets. Not single model fits everything. So that is why Xilinx and us aims to make reconfigurable hardware for different machine learning models, because we want the latest best model to be used when a new types of DDoS comes. The difference between the Xilinx and our design is they prefer random forest AI algorithm due to their AI accelerator, while our design reconfigurable neural net, which is the most popular strategies that research paper is working on these days. So this is the difference between Xilinx and our design. Xilinx is using the random forest structure, but however, we are going to put the learning part with the random forest algorithm on a CPU or GPU and get the best neural net model and upload to FPGA for DDoS detection. So next, we are excited to introduce our powerful solution and its beautiful architecture.
For the investor and experts in here, I bet you have heard a lot of solutions about hardware firewall for the DDoS attacks. So today we're going to introduce you why choosing us will be the decision that you'll never regret. The first reason lies in the reconfigurability of our product. It means that in Invest One, you're going to use it for a relatively long time. What does that mean? Imagine here a fixed architect with 3 multiplied by 3 convolution value followed by 2 multiplied by 2 exploit. If a new kind of data that comes, this simple structure without any ability to reconfigure it, they can do nothing to the new data attack. So we're definitely not going to do that. Instead, we're going to have a bunch of the PE arrays, and according to different kinds of configuration, we're going to activate different kinds of the PE sets, so then they can cooperate together to provide the protection we want. To be more specific, that is to say, when a new data attack comes, we're going to attack it on the CPU or the GPU. And then we will train a new AI model specific for it. Then we will translate the parameter of the new AI models to the buffer of the system, and then tell the control unit to activate the exact number of the P array, so that when next time the data that comes, we will capture it using our input and output FIFO. And so, because the P array is already working here, activated, ready to detect, we're going to target and detect the DDoS attacks. So that is to say, sum up a little bit, when new DDoS attack comes, we don't have to throw away any existing hardware we have. All we need to do is just reconfigure it, and the software-hardware co-design will help to update this. The second reason of choosing is lies in the elegance of our hardware, which could help you to save resources and also save your cost. So how's that fulfilled? The first reason lies in our P-array adopted structure called Iris. It was invented by experts in MIT, and this structure is famous for row stationary. Row stationary is good for memory access, and also good for computation and storage resources, because it could largely do the data reuse. And this part will be explained in more detail in another separate video. And below is the reference you can refer to. And the second reason is that we're going to adopt the quantization. Quantization is to set if we have input like floating point 64, floating point 32, we're not going to do that. Instead, we're going to project them into integer 8, so that inside our host system, we're not going to do any floating point calculations. Instead, we're only to use integer calculation, so that is good for computation and also the storage resources. To sum up, that is to say, for an investor, our reconfigurability can help you to buy one and use forever. So what are you waiting for? And for expert, we have collected the wisdom from MIT and used it broadly. So why are you hesitate? And for everyone like you and me, our product is definitely going to work, because DDoS can be everywhere, and every connection will count. That's all. Thank you very much for listening, and below are the reference list and some appendix for your reference.
So here's an image of network traffic classification. And this is the inner structure of our P array. P element.
And this is the convolution simulation results. This will be also introduced in detail in the separate video, but you can see here it's a 4 multiplied by 4 input feature map, and also convolute with the 3 multiplied by 3 filter, and it gets the results well. And this is the simulation result of the max pooling we have, and this is also introduced in the separate video, but you can see here the result goes.
So the system begins with data packet input, and the data was pre-processed and stored in the FIFO. And here is the grayscale image generated using MATLAB for DDoS data packet.
So this is like just a visualization for reference. And this is our... Yeah, go ahead.
So here's the input FIFO simulation result.
And thanks for watching.